Okay, next we're going to look at an important experiment, which is really to find out how much aluminium we need to block beta radiation. Now, the full name of this experiment is a method to measure the range of beta radiation through aluminium, and it's quite simple. You can see the apparatus here. We have a source of our beta particles. We have something that can detect them called a Geiger-Müller tube. We have a count meter that essentially counts how much radiation is being detected. A Geiger-Müller tube can produce a little click every time it detects an alpha, beta, or gamma particle. However, there can be that many of them. You're not going to be able to count them, so we need this count meter because it's quicker than a human being. And then we need a stopwatch to see how many of those clicks or counts we get in a particular amount of time. And what we're going to do is we're just going to put aluminium sheets in between here. So essentially what we do is, well, before we do any experiment dealing with radiation, the first thing we need to do is we get our Geiger-Müller tube, attach it to our count meter. We remove all the sources, or we don't bring them out yet, essentially. We have our little stopwatch, and there was a little method on the previous page that we used to measure the background radiation, okay? So we just leave that there without any sources. We time a particular length of time. I think in your notes it's 30 minutes, it could be an hour, it could be 10 minutes. It doesn't really matter. We see what the count rate is. So if we did it over 10 minutes, let's say we might get 190 in that. It's 10 minutes, we get 190 in 10 minutes, which means we get about 19 counts per minute. Okay, so that's our background reading, and that's always present. Before we do any experimenting with radiation, that's the first thing we have to do. Only once we've got that value can we then take any meaningful measurements. So after that, we'll get our little source. You haven't seen these yet, but they look something like this. So this is our beta source. And we do the same experiment again, only this time with the source present, okay? Now, we mightn't do it over 10 minutes. We might now just do it over 1 minute, or I think in your notes it says 30 seconds. So let's say we then do this experiment with the beta source present, and we get that it is, let's make it nice round numbers. Let's make it, what would we make it, 3,000. Okay, so with the beta source present, over the course of just 30 seconds now, we get that it's 3,000 counts, which means we could divide it by 30 to get the counts per second, or becquerels as it's called, or else we can multiply it by 2 to get the counts per minute. Doesn't really matter what way you do it, but if I did that, I would get, if I get 3,000 in 30 seconds, that means I would get 600 counts in a minute, okay, in 60 seconds, which means that I would get 6,000 counts per minute. However, 19 of them are from the background reading. So we have to subtract them, and it would mean I then get, what is it, 5,981. That's wrong. Yeah, that's right. Counts per minute. Okay. So you can see with this just little air gap, we get a large reading. What we then do is we do the experiment again. So this time we put a little thin sheet of aluminium in, and we get the count rate. Okay, so we take the count rate again over 30 seconds. We work out the corrected count rate down here, the one that takes into account the background reading. Let's say it hasn't dropped to 0. We put another sheet of aluminium in, and we just keep repeating this experiment, putting in more and more sheets of aluminium until this drops down to 0, which means the only thing we're detecting is the background reading. Another way of saying that would be that if we don't do this corrected count rate, the reading that we get without taking that into account should be 19. Okay, it should fall down to either 0 if we do the corrected count rate, or 19 if we don't do that. That's not the experiment over, because the purpose of this experiment is to find out the range of beta through aluminium. So the last thing we have to do is we have to measure this thickness of our aluminium using a ruler. If we're doing this experiment right, we would then go back and do it again and take an average of those values. Straightforward experiment. It's one that tends to turn up in exams a fair bit, so you want to know this apparatus, you want to know the method. The things people leave out is they don't do their repeats, and they actually leave out this one where you actually take your measurement. Anytime you're describing an experiment where you're taking readings from a radiation source, you always want to mention something about safety. There's usually one mark. Now, unfortunately, due to circumstances, you're not getting to see these in the labs. We are very, very careful with these sources. They're kept in a locked box in our prep room. The box is lined with lead, so the radiation can't escape it. When we use them, we only take them down, bring them into the classroom, use them for as long as we need to, put them back. I won't actually handle those sources because it's emitting radiation. The further you get away from that, the less of that radiation you're going to absorb. So we'd always use forceps to kind of hold them further away from your hand, as far away from your hand really as possible. We would never point them at the students, and we try and keep our distance from them at all times. So you can see there's a little list of all the things we would do to keep the use of them as safe as possible. Okay, you want to mention at least one of those whenever you're describing a method that involves using radiation. Okay, I'll put a little note down here. Next, we're going to look at the more mathematical side of radiation and how its activity changes with time. We're going to do a nice little experiment for this, but you will have to tell your parents or guardians to buy you some sweets to do it with. Okay, so they need to be either M&Ms really or Skittles. So they need to have a little letter on one side, and I'll show you that experiment next lesson.